Alright, guys, welcome back. Today we will be once again continuing our networking series. So, chances are you've probably seen one of these. This is called a Powerline adapter or Ethernet over Powerline. So, what this does is it uses the existing wiring in your home and it sends Ethernet or internet over the existing wiring that's in your house and allows you to get internet where generally there would be no internet. So let's say your bedroom doesn't have an Ethernet port and you want to add one. Well, you plug one of these in and now you have internet. And these work okay. I actually have one and currently still use it, and it works just fine. These are not without their problems though, but I consider these a better solution over a Wi-Fi repeater. And this is something that I also consider not necessarily a short-term solution, but I also don't consider it as a long-term or permanent solution. This is to me something, while even though for this example $95 isn't exactly cheap, where you can pick up a Wi-Fi repeater for as low as $15 on Amazon, it's more secure than Wi-Fi in some aspects, and it's a lot more stable. In fact, on one of these, I used to have everything connected to it: my Apple TV, my Apple Mac Mini, which used to host the server for my Minecraft. I had my gaming computer. I had my PS3 and my PS4 connected to it, and it worked really well. While I didn't get the full 200 megabits per second I get from Comcast, I only got about 30 megabits. The stability that it offered was more than enough for me. And that's again one of the limitations, is even though this one says 1200, which means you're supposed to be able to get 1.2 gigabits per second, you'll never see that rated speed at all. That's kind of a myth for these things. But if you want something that, stability and, reliability is more important than speed, which is where I have it now, which is a computer in the farthest room, where even though it gets Wi-Fi, I had installed it before. I had upgraded to my Wi-Fi mesh system, and it works just fine. So one of the biggest downsides to these things is the fact that it's using the wiring in your home over an actual Ethernet cable. But, it's not always economically feasible to run a new Ethernet cable. It can be very expensive, especially, depending on the type of house you're in or your budget. It's also, just a whole lot easier than using a Wi-Fi, repeater as well, or just getting a whole new router, because there's nothing to set up. So you just plug it into the wall, you press the button that's down here so they can pair to each other. One goes on the router end and the other goes on your or whatever room you need it to. And there it is, you have instant access. There's no configuring, there's no plugging in, a computer to, to set things up and put in passwords. Nope, it just automatically set up and it's plugged in and ready to go. These are also more secure than Wi-Fi because you're not broadcasting signals out to the open, which is important for some people. Like, let's say, you're in an apartment and you have, other apartments all around you. You don't necessarily want to be, broadcasting your own Wi-Fi to the rest of your neighbors. So you can have your router in, like, let's say it comes into where your kitchen is, and you can plug this into where your bedroom is, and now you have internet where you didn't have before. Since these communicate with each other, there's no hacker in the world, that I know of at least, that is climbing up telephone poles to look for, if somebody has a power line adapter. Two, they wouldn't know unless you told them. And three, by the time it usually leaves your house, the signal is so weak that it can't, actually be usable or be picked up by something else. These could also be daisy chained, where you can, it comes with two, and you can, buy another one by itself or buy another pack, and then now you have 4 of them and you can connect them all together. There is a limit of how many you can connect. That varies depending on manufacturer. I have a Netgear just like this one, the same model, a 1200. It works well for what I use it for. So how does this work? So in the United States, we have a split phase electrical grid, which means the house receives 240 volts, but it is split at the panel to a 120 volt for your regular, the one that looks like the surprised face on your wall. And then for the appliances like your electric heater, your electric dryer, your electric stove, your electric oven, even your air conditioning system, they use the full 240 volts. So in fact, I have the example here right for you. So here, thank you for the engineeringmindset.com. I'll link his YouTube channel below. He explains it a whole lot better than I can, and he goes in depth. What I'm going to tell you is kind of, the brief overview. So in the United States, we use 60 hertz, which means the AC electricity, which is alternating current, is moving 120 times a second. It's changing between positive, negative. Correction, at 60 times a second, which is 60 hertz at 120 volts. So to get the 240 volts, you have 2 hots and a neutral. If you actually look outside, if your electric power company connects your system via overhead cables, see that only 3 wires are coming into your house, and that those 3 wires serve basically your entire home. So at the panel, it is split. So essentially your house electrically is split in half. So you have 120 on one half of the house, 120 on the other half of the house. And when you need 240, you bring the 2 hots together to get your 240 volts. So at your wall outlet with the surprised face one is it's a hot and a neutral that are connected. So you only have 1 hot going to the plug. But on the 240, you have the 2 hots and then the neutral coming back. So that's how you get your 240 volts. So at the 60 hertz, since it's AC, it's operating in the United States at 60 hertz. So the way this works is we're sending this, they can both be either a transmitter or receiver. You just have to plug them in. So let's say this one here that's leaning over is the transmitter. It's plugged into your router. So in fact, I have that photo right here. So this one's plugged into your router. It'll actually send a different signal, which is like really, really high. That doesn't affect any electronics at all. So it could be, like 85, megahertz, 1 gigahertz, depending on, again, how the manufacturer feels like. So then it'll send it through the wire, back through the wiring in your house, and the other receiver here will be plugged in, and it'll pick up that signal, and then it'll decode it, which is basically a little mini computer. It'll pick up that signal and filter it out and say, okay, this is the Ethernet signal. And then you can plug in whatever you need, your desktop, your gaming console, your DVR, your smart TV, however you deem fit. So one of the main problems with these, and even though this has gotten better, since we use split phase power, they have to be connected on the same circuit. Because remember how I said your house was divided in half electrically? Well, so let's say let's say this router here is the panel, and where it says internet is, the electricity coming in. Well, since it's split phase, let's say the first phase is serving, the second floor, and the second phase is serving the ground floor. And, this is I'm just giving an example here. That depends on how the contractor wired the building, if there's additions to the house and everything, it's not cut and dry. But for those of you, because the thing is, if you don't have it on the same circuit, your performance really suffers, or you might not have any internet at all. So because if, let's say, this is on phase 2, but the router's on phase 1, yeah, it may go back to the panel and what they call jump the phase and actually, work, but your performance may, be even worse than what it already is already. So for those of you that remember the days of Radio Shack, we had one of these. So this is what we call a plug-in power, and this makes sense and is one of the best ways to actually test it if you have one of these, because this was the original home automation. So it came with this clock, and you had these modules, and you see here, maybe I can zoom in for you. You see there's the unit, where you would set the unit, and then you'd set the house code. So what you do here is your house, you put the selector here 1 through 4, and then there's 5 through 8, and then you could actually like have multiples of these where you can set it to like in this case 15 modes, and then you have the house code which will set up here, so you put it to A. So if you wanted to control unit 1 on house A, you would set here the unit to A, and then the selector on 1, and then with these buttons you would tell it to turn on and off. So they had different iterations of these. As you see later on, they came with wired ones, and then they had some of these which you can control appliances. So back in the day when you wanted your lights to come on at a certain time, you didn't have Alexa, you didn't have Siri, you didn't have Google, you didn't have none of that. You went to Radio Shack and you bought yourself a plug-in power. So you set the time, and there was a battery backup in this with a 9-volt battery. And let's say, you left your house at 7 in the morning. So you would set it, like at 7 to turn off all the lights. And if you had an appliance, you could have it turn off your coffee pot, turn off whatever you wanted. So, and then let's say you came back at 5 in the afternoon. So you would set the clock to whatever time you want. So in this case, 5. And when you walked in the door, the lights would already be on for you, and you didn't have to do a thing. And they even sold light switches that actually went in the wall, like a normal light switch, that could be controlled by this. And then later on, when they introduced the wireless part of it, you could actually have a security system where if it detected motion or an open window, it would automatically turn on a light or whatever you wanted to control, and it would, act as a security system to scare everybody away. So another thing you could do with the appliance one is a lot of people would have this as an alarm clock, where they would plug in like their radio or their coffee pot to wake them up. And so let's say at 6 in the morning, the alarm would send the signal, it would turn on the radio, so that way you could wake up. Or you could have it set to your coffee pot if it didn't have a timer. But by this time, everything kind of already had a timer in it. So you would set your coffee pot the night before, and you would set it to, let's say at 6 in the morning to turn on, and at 6:20 to turn the coffee pot back off because it was already done brewing. So this, not the wireless part, the wired part, is the reason why, is the prime example of how the 2 different phases in your house work. Because if the clock is on phase A, but the remote is on phase B, it wouldn't work at all. And the only way to tell was, you had to plug in what you wanted to be controlled, and then move the clock around to find out, hey, where can this work? And which is why later they introduced a wireless system, because it was just a little bit easier to control. And there was instances where people, if they were like in an apartment, where they would accidentally control their neighbors' appliances if they had one. But this is an example of why having it on the same phase is important. To be honest, why do you need one of these? Well, like I said, to me, it's honestly a niche thing. And like I said, it's not a long-term nor a short-term solution. It's kind of, the best example I can think of is, let's say, you need a computer in your garage, but you don't feel like wiring up anything, or your Wi-Fi isn't too strong and you don't feel like spending extra money on your Wi-Fi system because it works for everything else except your garage. Then, this is probably for you. If you really prefer having stability and, and reliability over anything else, and you can live with, like the almost half reduced speed in my case, and that's another thing, just because let's say you get a tape measure and you measure from the router to like one room and it's 50 feet, but the second room, which is further at 75 feet, the 75-foot one may get better internet, may get a faster speed versus the one that's closer physically, because electrically they're probably the room that's further might be closer to the panel or to the actual transmitter than the one that's physically closer at seven and only 50 feet away. So, and these things are also affected by other things, like the age of the house. Like an older house, it generally won't work as well as a newer house. Two, you're using unshielded cables, which are designed for electricity and not for communication. There's a lot of factors that go in. You may have an appliance that's kind of noisy electrically and you don't know it, and it may interfere with your signal. Like I said, this is perfect by no means, and is not something that I consider a permanent solution. But if you just want a quick and easy and relatively cheap solution to something that needs internet, but you don't want to like go through the hassle, or like in my case where I had a gift card from Target that paid for it by itself, that was given to me, so I essentially got it for free. Hey, yeah, this will work for you, but like I said, it may or may not fit your needs. Normally, if it was my opinion, I would actually just upgrade the entire internet system altogether so you can get what you need. But that's basically it, folks. I hope you learned something today and hope you have a good rest of the week.